For this lesson, we're going to be looking at our final functions for the course, and we're going to be focusing on periodic functions and sine and cosine functions. So let's begin with an investigation to get started. So we're going to look at the average monthly temperatures for Toronto, and on this table, we're going to graph the month versus the average temperature of Toronto. So below, I'm just going to put my months. Just going to space them out. So we'll have January, February, March, April, May, June, July, August, September, October, November, December. And now we're just going to plot our temperatures. So January was -3, February -3, March we got up to 1 degree, April got up to 7, May up to 14, June up to 16, July up to 21, August around 21, September is at 18, October down to 11, November we are down to 5, and then December is at -1. So we're going to connect those to try to see a trend. So as our year goes up, as our year continues, our temperature goes up, hits a peak in the summer, and then goes back down. If we were to continue this graph for another year, what would you expect? Would you expect a similar shape? Would you expect the shape to change? What do you expect here? And those questions are what we're going to be looking at in this unit. Let's look at another quick example. So Charlie is bouncing on a trampoline, and the graph represents Charlie's height above the ground over time. So just to go over this graph with you, Charlie starts right here, jumps up, then jumps down, and the trampoline lowers, then jumps up again, then jumps down again, and so on and so forth. So what is the initial height of our trampoline? What is the height that Charlie starts at? So if I look at my graph, and I look here, she starts around 2.5 meters. So that is my initial height of my trampoline. Now, what are her highest and lowest heights? So if I look, she jumps, and she's going higher and higher and higher until she reaches about 4.5 meters. Then she goes back down, passes her starting point, and trampolines tend to sink a little bit. So she goes to her lowest point, which is down here at 0.5 meters. Now, how long does it take her to complete one full bounce? So how long does it take for her to go from her starting point, go all the way up to her highest, then down and then back to where she started? That whole process of one bounce on the trampoline takes 4 seconds. Now, our last question, does this graph represent a function? So if we think back to Unit 1, we're going to look at our vertical line test. And if I draw a vertical line anywhere on here, it will never hit the graph twice. So I can say, yes, it passes the vertical line test. So these two examples are both examples of what are called periodic functions. And these are periodic functions, and they produce a graph that has a regular repeating pattern over a consistent interval. So These periodic functions repeat their y values at regular intervals. So you'll notice that the y values happen once, and then they happen again and again over our x values. So there are a ton of real-world examples of periodic functions. So seasonal variations in climate, variations in average maximum and minimum monthly temperatures, number of daylight hours in a particular location, tidal variations or depth of water. That one is a really good example of periodic functions. The phases of the moon, animal populations, certain motion. There are tons of examples that follow a periodic function. So let's take a look at that tide example and consider the tide cycles in the Bay of Fundy. So if I look here, my depth of water starts at 5. Then, as the time increases, so does the depth of my water. So my tide is coming in and the water is getting deeper and deeper until it hits about 9 meters deep. Then the tide is going to retreat and my water is going to get shallower and shallower till it goes back down to 5 and gets as low as 1. Then, after a few more hours, we're back at 5. And then that whole process of my tide coming in and out is going to happen again. So then my tide comes in, goes up to a depth of 9, goes back past 5, down all the way to 1, and then continues on forever. So there are a few important key features of a periodic function that we need to go over in order to understand our terminology. Similar to when we were looking at parabolas or lines or all of our parent functions, it was important to know the proper words to describe our functions. So the first one is a cycle. So a cycle is one complete portion of a pattern. So one complete portion of a pattern. So for this specific example, this whole pattern would be here. All of that would count as one cycle. Now the period is the time to complete the cycle. So in this case, how long does it take to complete one cycle? We're going to start here and we'll end here. So it will take 12 hours. So in this case, 12 hours. Next is our max. So our max is the highest point of our function. Which in this case would be the deepest part of our water, which would be here at 9 meters. Next is our minimum, which is kind of similar. So it would be the lowest point of the function. So in this case, we get all the way down to 1 meter. The next one, which is a new word, is our amplitude. So the amplitude is the measure from the axis of the origin to the max or min. So again, it is a measure from the axis of origin to the max or min. And I'll show you what I mean by that on our graph. So all of these periodic functions, because they go in this wavy shape, they have what's called an axis of origin. And that is this line right here that splits it all in half. And my amplitude is how big these waves are. So it's a measure of how big my waves are, or my amplitude, and I want to figure out how far our max and our min are away from the axis of origin. So that is our amplitude. So in this case, it would be 1, 2, 3, 4, 4 meters. Finally, our axis. So that is the mark where the graph returns to rest position. So again, that's the part where it cuts it in half, and that is our starting depth of our water. So how I can find that out is I would take my max and I would add my min and I would divide by 2. And in this case, our axis is at y equals 5. So those are the key features. Now let's look at a few examples. So what we're going to do is we're going to look at these and determine whether or not they are periodic. So remember, for them to be periodic, they're going to continue over and over the same thing forever. So A is definitely periodic because I can see that the same thing continues over and over. Now B is not periodic because it is not the same thing continuing again and again. Next, if I look at C, C is definitely periodic because I have the same pattern going over again and again. And D is not periodic because the pattern increases. So it's not the exact same over time. My y values are not the same pattern over my x values. Now, let's go through and state some of these key features of our functions. So the first one here, example 3, we're going to start by identifying our maximum and minimum. So I'm going to look here, I'm going to highlight my maximum point. So that would be here. How high do my curves or my waves go up to? So in this case, it will be 1. Now for my minimum, what's the lowest value of my y's? That would be down here at -3. Next is my period. How long does it take to go through one full cycle? So we're going to pick a starting point and figure out how long it takes to go through that whole starting point. So for me to go through one whole cycle is going to take me 8. So if I look to get from here to here is 8. Now my amplitude. So my amplitude is the measurement from my axis of the curve to my max or min. In this case, that's 2. Now my axis, or that dark purple line I drew, is at y equals -1. So that's where that line is going through. And now we have our domain and range. So if I look here, is there anything stopping my domain? There's nothing stopping my x's. So my domain is x as an element of real numbers. And then all my range is sandwiched between 1 and -3. So I know that y is an element of real numbers such that -3 is less than or equal to y, which is less than or equal to 1, like that. So these functions actually have equations. So the first one we're going to look at is our sine function. So what I want you to do is go through and find sine of all of these different angles. So I'm going to quickly go and write it all out, but you can pause the video and do it all in your calculator. So when you put all of those in your calculator, this is what you're going to get. So now let's graph it. There we go. So here is our sine curve. Starts at 0, goes up to 1, goes down to -1, back to 0. So that is our sine function. So that's the parent function for our sine function. Let's try the cosine one now. So we're going to do the exact same thing, but with cosine. So now I'm going to graph all of those values. So now we're going to start up here at 1. So our cosine curve is going to look like this. So that is the parent function of our cosine curve. So now let's address some of the characteristics of these two parent functions. So here they are again. So we have our sine curve on the left here, like this. And that is our sine curve. And then we have our cosine curve on the right. So let's address their characteristics. So first, what are my x-intercepts? So for sine, we have x-intercepts at 0, at 180, at 360. Now for cosine, we have x-intercepts at 90 and at 270. So right in between the sine ones. Now, what is my y-intercept for my sine function? My y-intercept is at y equals 0. And for my cosine graph, my y-intercept is at 1. Now, what about the period? How long does it take for one full cycle to complete? So, for my sine, one full cycle completes in 360 degrees. And same thing with my cosine. Next, let's look for the axes of the curves. So for my sine, the x-axis is splitting it right down the middle. Same with my cosine. So our x-axis is our axes for both of them. Oops, sorry, those were supposed to be down here. Now, what is our amplitude of the curve? So remember, we measure our amplitude from the axis to the max or min. So for all of them, our amplitude is just 1. Finally, what are our maximum and minimums? So our maximum values for these are just 1, and our minimum values are -1. So those are our sine and cosine curves. Later on, we're going to get into how to transform these and graph them, but for right now, I just want you to get comfortable with periodic functions and looking at our sine and cosine curves and understanding their key characteristics.